So welcome, good morning. We have a special session with Globus. You will understand. I met Vlas during SC recently in November. And I said, we need to learn more about Globus. And some of us here already navigate, search, etc. in order to
get some background.
Yeah, exactly.
Well, good morning, everyone. I'm Rachana Ananthakrishnan. I'm the Executive Director of Globus at the University of Chicago. So first of all, I'd like to thank Felipe for inviting us. We're really happy to be here. I have about an hour worth of material. I think he mentioned it's going to be an interactive session. I am open to dive into anything in this as needed, so please feel free to stop and ask me questions. So we are a team within the University of Chicago, and we build and operate a set of IT services, and that is made available focusing very much on the research market, right? And from the very beginning, Globus has been around for almost 30 years in various forms. From the very beginning, we've been a very mission-driven organization, and our mission is to increase the efficiency and effectiveness of researchers in science and scholarship. And we focus on sustainable software. We are obviously part of UChicago, so we are a nonprofit organization as part of UChicago, but we have a sustainable model for managing the software and building and operating it. So I'm going to spend a little bit of time on our evolution, just talk a little bit about how did we come about, what are our focus areas and such, right? So as I mentioned, we really are focusing on the research market, which means we are driven by the requirements and needs of that research space. And I want to just take a few minutes to highlight what we see as differentiators. What are some key aspects of the research space that have driven what we do? So the first here, from a researcher point of view, they are required to do secure science. So a lot of the science is protected, embargoed and such, and yet it is open. Ultimately, it gets published. There needs to be provenance. There needs to be the ability for them to show what the data looks like. And it's closely tied to the second point here, which is, I think, quite unique to the research market, which is the multi-institutional collaboration, right? Hardly any researcher today does science on their own, and it's not even teams within an institution. It's almost always they are working with researchers at other institutions, whether it's within a country or it's international collaborations. And another key aspect of that is it's not a classic B2B relationship. It's not like an institution A signs an agreement to institution B and everybody's covered. You have tens to hundreds of researchers at a given institution in a different domain decide to form partnerships or collaborations with researchers at other institutions. They have domain-specific requirements. They have data protection agreements based on what they're doing. That's quite distinct, right? So anybody who's developing a platform or serving the research market needs to be able to think about these diverse set of research use cases and these small cohorts all over the campus or an institution who are working together with researchers in other institutions. So how do you navigate that? And then the third one, as a product person at heart, this is such a key aspect, right? We are a horizontal service. That is, we serve all domains in research. We are not domain specific, which means we have to be able to figure out ways to provide this platform to researchers who already have domain-specific tools. I'm an astronomer, I have my own set of tools. I'm somebody who works in genetics, I have my own set of tools. How do we plug into something like that, right? So these are three things that an average researcher at any national lab, even a commercial research market, right? So in a commercial company within research space, this is sort of how they think about what they're doing and what they contend with. And then there's the other facet of it. What do they have to work with? So if I look at somebody at one of our customer institutions, on-prem resources, having storage and compute within their institution is pretty common, right? It is driven a lot by the funding model. A lot of the research funding comes from federal and state governments, sometimes foundations, and typically the institution has some on-prem resource that the researchers are making use of. Then the second one is really well-provisioned networks. It is not uncommon for us to see our customers with 100 gigabit connectivity between sites, right? And the leading edge, so some of our largest customers, the national labs and national facilities, also have 400 gig connectivity. So they have very well-provisioned resourced networks well, much unlike what we might see, it's not commodity internet that they're using, which then makes this next one critical, which is they have access to a large set of distributed resources. So the resource sharing is pretty common in the market that we play in. Often there'll be a national resource. For example, here in the US, a National Science Foundation has a project called Access that makes supercomputers or HPC systems available to researchers, right? But these are distributed all across the country. So I might be a researcher sitting in one place. I have to now access all of these, and the well-provisioned network makes it possible. Right?
How all of these researchers did this before? Because you identify the need, and it pop up in many different places, and say, okay, someone has to do something.
Yes.
So
that is my next slide.
Okay, sorry.
So no, that's fantastic. I'm glad. So we've been doing this for about 30 years now, right? So very early on, this idea of distributed computing. So when networks became a thing, when well-provisioned networks became a possibility, then started this idea of how do you use distributed networks. So Globus as a group has been doing this either as part of Argonne National Lab or University of Chicago for almost 30 years. And we have evolved. The technology has evolved, but the whole focus area has remained the same. So early 2000s, late 99 to 2001, evolved this grid technology. The idea that you could look upon the distributed resources as a computation grid, much like you would think upon the electricity grid, right? You could go in, you plug in, it works because there are well-defined interfaces. You have agreed on the protocol, so your machines know how to use the port. So that concept was defined. Ian Foster, who is the faculty director of Globus even today and the founder, is the pioneer of the grid technology. And he worked on this with two others, Steve Tiki and Carl Kisselman, all researchers here in the US. And they came upon this concept, or the idea that we could have these interfaces. And that has evolved over the years, right? So it's still the same idea. So early on, we were a toolkit. So we distributed software that you would all run. So let's say we had 15 institutions that were all connected very well. They would all run the software and provide the same interfaces to their compute and data so that users could access it over the network, right?
Does it mean at that time when you started to develop or at least identify the need, is there other project pretty similar like this coming from other university or research centers, labs, etc.?
Yes. So a lot of this time, it was all funded through research. National Science Foundation, Department of Energy, all of NIH, all of them funded a lot of this. And this also coincided with the time there was network investment. We were not at 100 gig at that time. They'd started investing in networks. You're right. Similarly in Europe, I don't mean to make this very US-centric, like Europe was doing the same, Australia was doing the same. In fact, a lot of the grid collaboration was completely international. So if you look at this, we built the software, the Globus team built this Globus Toolkit software that was distributed. But if you look at this map, it's a snapshot from 2008. This is a sort of downloads, right? It was all over the world. We had usage all over the world. And at that time, it was very much the best of software that we knew then. It was, you had to download, you had to install, and you had to manage it, very much a distributed software. And it was very successful, not only in terms of highly used, a lot of downloads, but high impact. So the grid technology was instrumental in 3 of the Nobel Prizes that were awarded over the years, right? So the first one is in climate, where it was used for distributing the data, the climate model data that was used in the IPCC assessments. Then this is CERN, the discovery of the Higgs boson. And then this is LIGO, the Gravitational Wave Observatory here in the US. They used a lot of this technology to be able to access distributed resource to make these insights possible, right?
I'm just thinking with the grid, it sounds like they could make a Hollywood movie starring Sandra Bullock and Keanu Reeves, like The Grid.
The Grid. You know? Yes, it sounds really cool, doesn't it? And there's a book to go with it too. So this is, I mean, you can see this is, we are, 2007, 13, 17, sort of the three wins there. But we started thinking about, in about 2008, 2009, we started observing how the market is taking the product. And this actually was a study funded by the National Science Foundation, where we actually did a full deep market research, trying to understand, okay, who is benefiting from it, and what are the parts of the market that we are not serving, who's not able to take advantage of it. And the realization was that there's a very long tail in science. And what we mean by that is that there is a lot of well-funded large projects which have people who can do IT administration, stand up these services we were shipping to make all these resources available, help the researchers and such. And then there were these really small labs which had like a couple of PIs, some grad students who were doing excellent research, but they didn't have the ability to use the kind of software we were shipping because you needed IT expertise to do that. So we were really missing those people in this, and only people who actually could install services were using it. This was also the time where the cloud computing had picked up. So you could see on the commercial space the impact of going the route of hosted services, and usability was a thing and such. There were 3 other pieces I want to highlight here. We are also seeing the spectrum of workloads changing. So if you look at the examples I gave you, high energy physics is very classic HPC user. They've been long-time computational users and things. But then we moved to seeing a little bit more of near real-time usage. People started doing more interactive usage of compute. And that's not something that product was particularly serving. Then the diversity and the background of the users, right? It was no more our computational chemists and people who were doing large simulations. It was moving into other markets. People, social sciences had data that had come in and they were trying to analyze that, right? If I may dare say, humanities was starting to think about it. So you started having these different kinds of users who were not traditional, very technically savvy, if you will, who were willing to sit in front of a HPC machine and do that, and that changed. So we started thinking about how do you lower this barrier, and we had seen what was happening in the commercial crowd. So Ian Foster and Steve Tiki, the 2 people there, decided they were observing what was happening, and there was a big product pivot, and we moved to Globus as a software as a service and platform as a service. So we thought about how do we make these services and these capabilities more accessible. So we pivoted to that model. Do you have a question?
You talk about the product. So do you give it for free, or is there any kind of price? Is it protected by any kind of patent?
So it is a freemium product. So I do have a section in the end where I talk about our revenue. It's a freemium product. Some is free for nonprofit research, and then we have a subscription-based model. And UChicago holds the IP for the product. So I'll talk about it. I have a section on that as well. So we pivoted to a platform as a service and a software as a service model with the idea that we wanted to reach those millions of small researchers who don't have huge IT infrastructure. But we had 3 stakeholders. We wanted to make sure we were reaching researchers. So we wanted to be easy to use, browser-based, simple workflows. We wanted to make it easy for system administrators. I have on-prem resources that I'm managing. For how do I make it easy to make available for the researchers? How do I make that policy management easy, administration? And then our third stakeholders was developers, right? So we decided to do open APIs. So Globus has open REST APIs, so it's an extensible platform. You don't have to, it's not a SaaS only, so you can come in and build your own applications. And if you think back to my first 2 slides, when I talked about this puzzle where every domain has its own tools, we wanted to make sure that you can take what we're doing and plug it into these tools, that you are not committed to our SaaS. You could use our PaaS and plug it in, right? This was released at SE 2009, I think, or 2010. I forget which was our first year. So 2009, 2010 it came out, and we've been very successful. We have users in over 80 countries, so it's lots of downloads all over the world. We also, one of the big value proposition of the product is this 2000 number that you see, identity providers. What that means is that we connect to institutions' authentication systems, over 2,100 institutions, through these research federations. There are research federations here in the US, Australia, Europe, actually a lot of the countries have. So these are the 3 big ones. So we connect through that, which means if you're a user from one of these institutions, you can log in and use Globus without having to create new accounts, no provisioning, nothing. So it's just ready and available for you, right? So that's a big piece. And then these numbers you see here are storage systems that are connected into our ecosystem all over the world, right? So users of those storage systems can log in and use Globus and such. So some of these numbers here are 12-month rolling numbers at this point.
So this is massive. What I mean by that, when you see this number, especially the number of registered user and
Yes.
apps,
Mm-hmm.
it's used on the planet almost everywhere.
Yeah.
And so
already-
there is no real competition or alternatives.
Yeah, so yes, as a platform, there isn't a direct alternative. But when I talk through the product, you will see that some of the capabilities you may see with one vendor or the other, but we are vendor agnostic. We are already plugged into all the research ecosystems, right? And we have a subscription base across the world. So as a platform of end-to-end solution, you're correct. Right? And we won a couple of R&D awards in this, right? Most coveted awards here for us. One way back in 2002, we won for the toolkit. And then when we pivoted again in 2012, we did. Yes, sorry.
Excuse me, I'm sure I'm missing something. Just to be sure to understand, actually the solution is you connect the client directly to a server, or the server and the client have to share something through, I don't know, something in the cloud that you host.
Yes, that is my next slide. So I'm going to
Okay.
tell you that one. you are all awesome audience. You just set me up just right there. Okay, so let's talk what's the product, right? Okay, I've talked all about so I need to tell you how we're doing this. So it's a hybrid SaaS. So I'm going to show you the architecture picture. But just from a capability perspective, the Globus platform has capabilities for data management. So it's managed data transfer, collaborative data sharing. So I talked about how in research space, that's a critical piece. And then doing this across different systems. We have solutions for metadata management, compute, remote job execution, accessing remote systems, and then automation, right? So those are the capabilities of the system. But here is the architecture to answer your question. It's not a pure SaaS in the sense everything is not in the cloud. We can't do that because all the institutions own their own resources. We can't sort of take over those resources. We have to figure out how to add valuable services as a layer to that resource, right? So the institutions have all kinds of resources that you can plug into Globus. You could take an instrument or a lab facility and say, I want that to be a part of the Globus ecosystem, compute, cloud, if you have on-prem or cloud storage, and then any services you use as well. Then we distribute agents, right? And there are different kinds of agents, and these are local agents that an institutional administrator runs and says, now I want to plug this into the Globus ecosystem so researchers can use this resource using Globus. And these agents, the one in the blue is a data agent. It knows how to do data management pieces, and it is local to it has plugins for your particular data type, data storage type. The orange one is same for compute. It can speak Kubernetes, Slurm, PBS, and so on. And then this is for any APIs that you have. If you have a service that you're running, you can do that. So I'm just going to finish 2 layers, and then so the administrator or an institution runs these agents. They define policy, what can be exposed, who can access, and all of that. We run a global service, a management service that provides all the reliability, all of the management, heuristic-based optimization, orchestration, and such. So the users come in and say, I want to move data to this service, and then we use the agents to be able to manage the data movement. And I'll show you each of these in detail. But overall, this is the high-level architecture. And all of this is connected using a security fabric. We use web-based authentication mechanisms. So we use OAuth and OIDC are the standards. It's an industry standard for how you do this. So there's fine-grained authorization across all of this, managing how this speaks to this and this speaks to this and so on, right?
So can I just ask, the big buzzword of 2025 and 2026 was AI agents, agentic AI. So any of these agents using a bit of AI?
Yeah, absolutely. So one of the things that we are right now, how AI is being used in our system is a lot of the compute agent is being used to do AI ML workloads, right? And be able to access that. So there are several use cases where that is being deployed. And the security fabric that we have that connects all of this is something that we are looking at for supporting agentic AI. So you can imagine agentic AI is something that is like this, conceptually. The security fabric is very rich in its capabilities and security, so we're using that in that context.
So every client, servers, and so on connect to the global management and orchestration, at least to login,
Yes.
I would say. Okay. But the travel of the data, does it go to the cloud? No, it's
No.
direct.
So here's my data, the next one. so this is fantastic.
You know when you're getting asked good questions, that people are interested, and the next slide is the one. It's wonderful to see.
Yes,
Wonderful.
I am thrilled. So this is great. So I'm going to go through each of the capabilities, right? So let's talk about managed data transfer. This is the first one we introduced way back in 2009. So this is our oldest one. It's been around for a long time. So how does this work? So this is this managed accessible system. These are institutional machines where they are running these agents that I talked about, right? So policies all defined by the administrators. They define who can access, how often do they have to authenticate, who they have to log, which identity they have to log in with and such. So researcher contacts the Globus transfer service. Typically, it is just done using the web browser. It's a SaaS, right? They come in, they discover this one, they log in, okay? And then they discover this one, they log in. And then they tell Globus, move data from here to there. So that's this command. Globus then sets up only control channel connections. So it's only sending commands through to say, I want to move data. And it is getting back restart marker, like checksums, markers, so that when the user comes and says, where is the data? It can tell it how much has moved. But the file data itself only moves directly from source to destination. It never goes through us. I mean, it'll never be performant if it goes through us, right? So this is where the research network comes into play. If you have bandwidth of 400 gig, we can use the 400 gig. If you have 100, we can use 100. Whereas if one side is 100 and this side is only connected to 10, we know how to make sure that we are not overwhelming this machine by sending too many bits, right? That's the kind of smarts that is built into this. So that's what I mean by heuristics driven. We look at the request wholly and say, what is the security needed? So do I need to prompt the user? What do they have to do? What does the bandwidth look like? What is the machine capacity that the administrators talked about? Then we use all that and optimize the transfer. From a user perspective, it's just a fire and leave. And the transfers can be anything from move one file to we recently, early last year for a climate project, 7.5 petabytes of data were moved between 3 national labs here. It took months, but for them, it was just a request. That is all taken care of here, right? Before this, to your question, before we did this, the user would have to connect to do this. So you are running some client that is keeping track of state. Did my file move? Did it fail? How much moved? Do I restart or not? All of that was run by the user. All of that is completely taken care of for the user, right?
And if there is a problem, actually, because the connection breaks
Yes.
or I don't know.
Automatic retries.
Yes.
So,
and,
yeah.
What happens actually? I order the transfer from and the transfer starts, but for some reason
it happens
the
all the
link
time.
breaks.
Yeah.
So what happens?
So the protocol here continuously sends what are called markers. So it says I've moved 5 bytes, 10 bytes, 20 bytes. Then suddenly there's no marker. Then this keeps retrying with a back-off algorithm for a period of time, right? And it gives it if there is no bit moved for 3 days, then it gives up and tells the user I can't move. But it just holds onto it and just keeps retrying with a back-off.
Is it using like a BitTorrent type of?
The protocol here is called Grid FTP. It's a high-performance FTP protocol that is a well-published protocol. That's from research over the last 30 years. Yeah, that's the protocol that is being used. It also assures integrity, automatic checksums. If checksum fails, it retries. So all of those are built in for the user without the user have to worry about sort of managing that transfer.
I have a more global question about who is able to develop, even if you offer an API, who is able to develop an agent, a function, something?
Yes, very good
because let's say Stanford here wish to develop something not yet available in the list of the agent you provide.
Yes.
So do you offer this?
Yes.
Are you playing like a steering committee with submissions?
It's the next slide.
It's the second slide from now. I'm one off. So I'm going to do one more slide and then I'm going to address that one. So just like we can do file movement, we can also do streaming, right? So if you are sitting, for example, if you're in an instrument facility and you're gathering data and you want to stream data out, for near real-time processing where you want to do a feedback loop, because we already know how to do secure wide area connections. And the main thing to remember here is, for us, our bread and butter market is that these things are not in the same institution most often. They can be. There is a lot of intra-institution transfers, but most often you're doing this across multiple security boundaries, right? And that's where we excel. That's kind of where our value proposition is.
And the thing is, you need this sort of system because you can't just query your hard disks over.
Yeah,
I mean, petabytes of data
exactly.
is just...
It's
It's got to be
right,
done over the network.
We are used for, this solution is used everywhere, from a telescope in Chile, National Solar Observatory uses it for a solar observatory in Hawaii that transfers data to Colorado. Globus is used for that, and then they distribute the data using Globus. So you can think about all these cases where how would you manage this? And they're able to just outsource and say, just do it and let me know when it's done, right?
But you're in fact only managing data transfer.
Yeah, that's one part of the product. So this part of the product, there are 6 pieces to the product. The first one is managing the data transfer.
Okay.
Yeah.
And then later on you get...
Yeah, I'll show you
processing.
each one. Yeah.
Okay.
Yeah.
The next slide.
Yes. This one is for you.
Yeah.
This is the folks in Australia, Arnet. They are one of our big users and partners. And this was recently published. So many of this I'm talking about are published studies, so you can go look it up, these user stories. And they enable their National Transport Research Organization. So they have these vehicles, all of them have a Globus agent running on it, and as data is collected, it is being sent to the cloud using Globus, right? So on the go kind of thing.
In the back of this is a data center or something?
They have some kind of a machine that's gathering the data, it's running in a Globus agent, and it's shipping to the cloud.
Sweet.
Right, so that was one of the most recent ones that was published. So so this is another example where there's a more systemic deployment, right? The whole system uses it. So to your question about how do we plug in? So I talked about the heterogeneity of the resources, and that's a key part of what we are trying to enable. So these agents the data agents have a concept called a connector. It's called a Globus connector, and it's extensible, right? So you can build connectors of different types. What it lets us do is give you a unified access to the data that is stored in different systems. So it doesn't matter if it's an object store or POSIX or tape archive. From a user perspective, they have the same API to access and say, move the data or share the data. Also, interestingly, it abstracts all the security aspects. So if you're using Google Drive, you have to manage Google tokens. If you're using Azure, you have to manage Azure tokens. With Globus, you can log in with your institutional credential, and Globus manages that translation for you and manages all of those pieces. It also manages the limits. If you're using Google Drive, you have 24-hour limits. So if you submit data transfer and you've used up your API limits in the first 1 hour, you have to wait for 23 hours before you start. But that's all managed by our service. So the user just says, move the data and let me know when it's done. So all of those pieces are built in. So it is an open ecosystem via, to Felipe's question, called a community connector program. We have a huge set of connectors that we provide. Some of it has been built with partnership with the vendors. Sometimes we have had vendors come in and say they want to build and test connectors. Many are driven by our customers. So when university started using Box, we did that. When people started using Dropbox, we added that. There are a couple like iRods, that's a partnership with the university. I think somebody mentioned Raleigh, so they're out there. It's a partnership with them. They've built the connector, we build the piece that glues it, and it's a shared support model.
But there is some also overlap because they provide some function you provide as well. So
there are some parts of iRods, yes. But if you have an iRods deployed system, you can use Globus for moving data in, sharing, and all of the functionality I'm going to talk about.
Is it true to say that one of the key majority use case for you, or where you are selected, is for this grid FTP, this data movement capability?
So its data management has been our longest product. So definitely that is, so both data movement and sharing. I'm going to talk about that next. Those are the big use cases, and compute is our next one. So those are the reasons they picked Globus.
Yeah, you will explain the compute part?
Yes.
Yeah. Okay.
Next slide.
So on that,
Yes.
the connectors are open,
Not all of them, depends.
all.
The HPSS connector, for example, is open source because it was funded by a university to build, and it's been open source. Some of the other connectors
the
are not.
platform itself is closed.
In a sense that you can't have somebody build a connector and then just use it with Globus. They have to speak with us, and then we go through a testing process. We have them run through a test and validation process, and then we list them in this. So they can write, like iROD's connector we don't own. The iROD's team has written it and they manage the code, but you can't just use that connector without working with us. So you go through this community connector program and we certify. I mean, it's a partnership. We do a test and validation, make sure that they're committed to keeping it updated as we update our versions and things. That's it. Okay, this is another example. The European Biomedical Institute, they use Globus for distributing all of their data. And again, for them, the idea that their users can come in and get data from there, but move it to storage systems of their choice is a big part, right? So you don't have to worry about whether we support it or not. Okay, second part of this is data sharing. So the first one is about moving your own data. I have data sitting in one system. I need it somewhere else for various reasons. Data sharing is used, or somebody's publishing data, I move it. With data sharing, it really is the idea of I have a collaborator that's sitting in another institution and I want to share some files with him, right? So then I can go to a system that is a storage system connected to Globus and say, share this folder or the set of files with this collaborator. And I set permission using the collaborator's institutional identity. So I could share with somebody at stanford.edu, somebody at somebody's GitHub account. So I could share with them. The user then authenticates using that identity and copies the data out. There is no data replication. There's no staging area here for data. There's no new account provisioning, none of those. It's a permission overlay that Globus maintains on the storage system to allow you to share the data, right? So that's a big part of the value proposition. In addition to transferring data, data sharing is another big part of it. And there is a lot of controls around it, of course. The administrator decides who can share, where can they share from, and such. You also have time-restricted sharing. You can say, I want to share, but only for the next 24 hours, as soon as they download, remove permissions, and such.
So a local share can become a global share with Globus.
That's right.
Okay, so I have a NetApp filer with NFS local sharing across my different,
Correct.
let's say, machine, and I had this service on top,
Yes.
and now I can share my data hundreds of thousand kilometers away.
Yes, provided your administrator allows it.
Okay.
Yeah.
But on the client side, what can I see actually? I see on NFS just a directory or hierarchy.
So locally, the files are owned by the same person. So let's say I have files sitting at University of Chicago. I have a local account. I own the files, right? Then my administrator allows me to share. Then I come in and I pick a folder. Let's say it has my PowerPoint slides I want to share with all of you. I can come in and set permission for you to access that PowerPoint file. When you come in, Globus has logs that says you authenticated. There are local logs in the agent that says you logged in. But the local file system permissions are still me. We don't have to create an account for you.
Yes, but on the client side, so I want to access some files that are shared.
Yeah.
So,
what would you
how
see?
can I do that?
I see.
Should
Yeah.
I connect to a website?
Yeah, so you go to
Okay.
globus.org. Actually, maybe I'll pull up the website and show you in a little bit here. Just if you have the time, you just go to globus.org and you search. First of all, when I share, it sends an email to you. There's a link to what I share. So you click on it, and then it just lists the files that you have permissions to.
Okay, it's not like a mount directory.
It's not a
mounted
mount directory, no.
Okay.
And then you move it to your laptop, right? And you can do the same sharing across any of the systems that we support. So you can imagine a collaboration a researcher has with, or a work somebody has with people, and they have some data in Box. They have some files in Dropbox and some files in a local NetApp system. They can just use Globus to share on any of these as long as they're connected. You don't have to figure out how to share on each of these different systems, right? So here's one international consortium called the Telomere to Telomere Consortium. And what their goal was to fill the last 4% of the human genome that was not completely identified in the Human Genome Project. Apparently 96% of the genome was identified, right? But this was a huge collaboration across the world, and they needed a way to securely share the data the researchers across the world needed a way to securely share their data, and Globus was used to do this, right? They stored it, that's how they stored permissions, so they didn't have to create accounts for everybody in all these different sites. So that's the main idea here.
This one's
As you are managing this system, who is managing the accessibility? For instance, if you have a US institute that's working together with a European institute, and all of a sudden, from geopolitical reasons, the US government says, oh, I don't want that anymore. I cut the line. Is that possible? Is your system protected against that?
I mean, we are a U.S. institution, so
Yeah,
we have to
exactly.
comply with the U.S. laws, right? So
That's
it's
the question.
Yeah, the Globus service is being run within a U.S. institution, so that's all I can. I mean, we have a lot of European subscribers. We have about 35 to 40% of our usage is from rest of the world, and I'll show you subscribers from outside. But yeah, if legally we have to comply with whatever happens here. Right.
So then we have an issue, because in Europe people are really wondering how to cooperate in the near future with companies due to that what is happening on the geopolitical side.
I mean, the part here is that any of the agents I'm talking about, the interfaces we provide, are layers on top of your infrastructure. So none of your data comes to us. You still have all the native interfaces. So let's say you take an S3 deployment that you own and manage on AWS S3 and connect it via Globus. Globus becomes another way somebody can access it. We don't take control of your S3 buckets in AWS instance. People can still use S3 interfaces, right? So if something happens and you decide you don't want to use it and you disconnect Globus, yes, you lose a lot of the ecosystem you've built, but we are not taking over your storage. Unlike some other products where, the product essentially takes over the full, even the native interface of the storage. The native interfaces of all storage systems remain with you. We add a layer. So that's a little bit of a de-risking that happens there, right? So compute. So I talked about two databases, compute. It's a very similar concept. So the idea was you have all these heterogeneous compute systems. How do you allow somebody, I'm someone who wants to have to run a job on this machine sitting in one institution, and then I also happen to have a partner who is able to give me some cycles on another one. How do I run all that, right? So what this product does is it takes function as a service paradigm that is there in commercial cloud providers and makes it possible in the research environment, right, on an on-prem environment. So all you need is a Python code, essentially. And then right now we only support Python. You take the Python code and you tell the Globus service, run this function on these endpoints that have these agents running, right? Again, we are not providing the compute resource. You must somehow have it, right? But then the user is simply doing that, and then Globus manages all of it. It ships it, it runs it, it manages the execution, makes sure that it's getting status, and then the results are returned to the user.
So it's a bit
right?
like a scheduler.
It interfaces in front of the scheduler.
Yeah.
So it doesn't matter what scheduler is used here. You could be, you could be running Fork, you could be running Kubernetes, Slurm, PBS.
Slurm, yeah.
It has all the plugins for that. But the user doesn't have to know all of that. They just say, I want to run here. I'm out of cycles here. I want to run here. I want to run the debug queue, now production queue, right?
And so just to be sure to understand, because I went to your website to see this compute feature, and so there is some Python on both sides, but is it only for executing some Python code, or can I execute anything?
Yeah.
But I need a Python just to launch.
That's
to
right.
run
So this layer has to be Python, but whatever you're calling, if you already have an executable, a C executable, or something here, and that Python code calls it, you're welcome to do that, right? Okay. So just this, whatever function we take in and push has to be Python, but then everything can be anything else.
Okay,
so here is one example, right? They did machine learning-based drug screening. So you have 4 billion molecules. They're trying to screen that as quickly as possible, and this was done for COVID, actually. And they were trying to use resources wherever it was available, right? This is Argonne, this is Texas, this is NVIDIA giving us a DGX system. So the researcher just wants to be able to run the same code, if you will, just right. And Globus Compute is running everywhere. From a researcher perspective, they're just saying, here are the tasks, run them wherever I have cycles as much as you can. If this goes down for maintenance, okay, pause, run here, So the client is not changing their code. They're not changing what their client infrastructure looks like. They're just calling Globus Compute with a function and a target execution resource.
And so I run the application from remote office, and so I see on my from the remote office, I see the result on my screen. I see where the data is saved. Is it on my computer?
No, the data will be saved. I mean, some of the results can be transferred out. If you choose to transfer the results, sometimes they do because they're not very big, then the results can be returned by Globus. So there is you can call back here and get the results, but sometimes it's very big. So then it is just saved on this machine. Here is where Globus transfer is often used with compute. So people will say compute and then transfer the results to my home machine.
Yes, okay.
So those two are put together often. It's called data stage in and stage out.
But at the very basis, actually, it's like SSH.
Yeah.
Yeah, okay,
Yeah.
so I order the
Anything,
I run the command from...
anything you do with SSH, you can do with this. What are your permissions for? Exactly.
Okay.
Yeah.
So can I ask, and it's probably on the next slide, but, but seeing as it's obviously a massive enterprise to have set all this up. This has been set up for some time. You've set up all these global standards. You're linking with everybody. I mean, it sounds like anyone, any university or any organization that wants to try and do something like this is going to have to reinvent the wheel. So why are you here telling us about you if you're the only real choice and everyone already presumably knows about you? I mean, which new customers are you looking for that you don't already have?
I mean, so first of all, there are two facets to that answer. One, we are used in Europe and rest of the world, but we are a very small team punching way above our weight in terms of marketing. You are seeing our marketing person there. Yeah. So we welcome opportunities to be able to get the word out and get more people using this, right? So certainly, I think we take every opportunity to do this. So that's one facet of it. We would love to get more coverage and people learn about it. So within the US, our target markets, the national labs, university systems, we have quite a bit of adoption penetration, especially in the larger ones. So now we're working on the medium and the next one. And then the next set of segments we're looking at are independent research institutes, right? And then hospital system and academic centers. So those are picking up. So getting the word out to say, these are capabilities that you could use. So that's one facet. Second facet, our platform has continuously evolved. Transfer was 2009. Sharing was, I think, 2013, 2014. Then we did, I'll talk about metadata management. We've done compute. Compute has been around only for about 4 years, so the adoption is not as much as data as you can imagine. So there's also, within our platform, getting the word out about the platform capabilities going is the thing.
Yeah. So you're forever evolving. There's all this new AI stuff that you haven't even really had a chance to speak about yet, and you want more organizations to use you because you exist and you serve a great purpose.
And network is the key, right? So talking about hospitals and academic centers, so we can be used for protected data. So by that I mean anything from PHI, PII. So we follow NIST controls here, which maps to controls in Europe and Australia and other places. Those are the two NIST controls. We also sign GDPR and DPA. So all of the customers we have, and then UK also has its version. We sign all of those. And you can use this for compliant data sharing. So it is used quite a bit because the data sharing capability I talked about is covered by all these controls. If you have PHI that you need to share in an institutional collaboration, or if you have an IRB study, an institutional review board study here in the US institutions where we get permission to share, you could use Globus to do all of those. You sign a BAA, Business Associate Agreement, with the University of Chicago for that, and that's part of the paid tier. So I'll talk about that, right? So two other parts of the product. One is around data discovery. So we talked about the actual data, then we talked about compute. This piece is all about metadata management, right? Globus provides what we call Globus Search. It's a hosted search index. We leverage AWS heavily. Everything we do is AWS based, right? We run on AWS. But there are two main differences of why you wouldn't want to do this, right? Other than the fact that maybe you don't want to run and operate an Elastic Search or OpenSearch cluster and manage all of it. It's a hosted solution, but you get those other places. Two things. One, we are plugged into the research security system. So we understand that in the research market, some of the metadata would require visibility controls. Sometimes the data is embargoed. You could only provide some metadata about the data, but not everything. So the search service adds to Elasticsearch a value-added piece, which is essentially this fine-grained visibility controls on the data. And it's also schema agnostic. In a sense, you can pick whatever domain you're in, and you say, I want this search index to be about this, and or dynamically detect the schema. So sometimes when researchers start new projects, they don't know for sure exactly what the schema is going to look like. Some domains are very good at it. They have well-established schemas. But this search services schema can do dynamic schema. As you put data into it, it detects the schema and creates the schema for you, right? So those are the two big differentiators. And essentially, query, discovery, all of that can be done. And this is a Canadian example. This is their federated research data repository. This is a national resource in Canada for any researcher who wants to publish research data, not just the publication. And it uses Globus search. It includes support for geospatial search and all of that, so that they're able to provide all kinds of domain data for a researcher to come in and discover it, right? And then the last piece on the product is the automation. So this is also the most recent piece. So the problem we were trying to address here is, if you sort of look at a research data lifecycle, or even what a researcher has to do to get their job done, they typically end up doing lots of different tasks. First they run something here. After that is done, they wait then they come in and maybe do some analysis. Then they do a second analysis. Sometimes they review all the data and say, okay, do you want to process more or not? Sometimes they have to call out to other services. So these are distinct tasks that have to be done, and often it is automated using scripts. People write some scripts and make sure it works. So we looked at this and said, how can we make this simpler by providing a service that can do hosted automation? So in this service, a user comes in and defines a flow. The service is called flow service. Defines you can think about it almost as a state machine or a flow chart. Do this, if it succeeds, do this, if it fails, do this, sort of thing, right? They actually define their steps. And then they submit it. It's defined in a declarative language. It's a JSON. We have some tools for them to author it. And then they submit that definition to Globus. And the Globus service manages the automation. So you can run that flow. After you define the flow, you can run that flow. And then the flow calls each of the steps, provides the reliability, error handling, and all, and so on. It's event-driven execution, and it heavily uses step functions. AWS has a service called step functions to do exactly what I'm describing, but only within the AWS ecosystem. You can use all their services. We took that and have it now securely call outside services, remote services, right? So one very good example of it is automation from an instrument facility. You're gathering data from an instrument facility, typical workflow, you move it out of there, you process it, somebody looks at it and says, is this sample good or not? If it is, then they do a full reconstruction. Then they may extract metadata, get a digital object identifier to publish it. So we are seeing quite a bit of use of this, where instrument facilities define these flows and they are run as data is gathered, right? So that's automation. So I'm going to give you a couple of examples on automation. This is Franklin and Marshall College is a small liberal arts college here in the US. And I put this example in because we always thought about flows as, how do we bring scale? If you do this, you can do lots and you can do it big. But these guys picked up, they are our subscribers, they picked up flows, and the feedback we got from a biology professor was, it really increased the community participation. In place of teaching all his volunteers how to do these 10 things, he defined a flow, and you can go to the Globus web app and click a button, the flow starts, they fill out a questionnaire, and then you're able to process the data from the field, right? It really was not about scale. It was about adoption, accessibility, broadening use, which is fantastic to see, right? A really small school there.
And speed.
Sorry? And speed, absolutely. So he has like people walking around taking pictures, field research, then they on a flow, they send it, it processes it, and puts it into their piece. Rosalind Franklin Institute is using actually all of this. They're using sharing, transfer, automation, And they're using this for all through the data lifecycle. You can see Globus is in every part of their data lifecycle. They're one of our really engaged subscribers. They also use our platform quite a bit. And the other end of the spectrum, you have Franklin Marshall, and then you have Advanced Photon Source. It is the brightest light source, I think, and it is a Department of Energy facility in Chicago. And this is the beamline. And you can see each of the beamlines has picked, whether to use Globus or not, and you can see all these symbols. So these are all for data, moving data out of the beamlines. These beamlines also use Globus for computation, right? And they have flows that they've defined. Each beamline has a different flow, different event that tells you when the data is collected, when it should be processed. And they're using it in production to be able to quickly process data that is coming out and make it available to the researchers. This is a user facility, so that means people from outside come in and access the beamline. And some of the best feedback for us are things like this, right? They went from solving a structure from weeks to now hours, because Flow just processes it automatically as the data is being collected, right? And then the last example, before I move to the revenue section, I wanted to talk about, we are seeing a huge use within AI ML. Everybody's doing, the market itself is shifting. Every researcher in some way or shape is doing something in that space, right? But here is an example where they are looking to gather data at Slack here in Stanford, right here, exactly. And when they process the data at Slack to do some machine training models, because they don't have the specific kind of compute that they need, it was taking more time than it would take to move the data to Argonne, where there is a Cerebrus machine, which is tuned for this, does the machine learning model, passes it to the edge, and then the data, it's sort of doing a smart instrument, which is able to use the feedback loop. And they use Globus Flow to be able to do this. Move the data, process, bring it back, move the data, process, bring it back, right? So those sort of integrations.
And to write the flow, actually, you have to know to write a script, or is it something?
It is JSON.
It's JSON.
JSON, and we also have a UI.
Okay.
So you could
have
say,
a UI.
yeah,
Okay.
you could say, draw. It's. You need to know. It's not as much as a drag drop icon. You have to be able to put, but we have a IDE, like an editor.
Okay.
And we have blocks that say, here's a transfer block, here's a compute block. But this is extensible, so anybody can bring a new service into the Flow service. We have a group, materials group, that has its own API for doing metadata extraction, and they have written a plugin to be used with flows. So that area is where we are still investing. How do you take something custom like that and give people a good, but yeah, it's not Python, it's JSON that they write.
Okay. And
sorry, one more, just from use perspective, it's write once and run thousands of times.
Okay.
So typically, a beamline scientist is writing the flow, or a research software engineer is writing the flow, and the researchers are mostly using it. And for that, we have both command line you could use if you want. We also have a web application where it detects the type of input the flow needs and gives you a form and detects the type. So if it's an integer, it does validation. If it is a type of Globus collection, it'll allow you to find a collection, so that sort of thing.
And I had one more technical question remaining before you go to the revenue slide.
Sure.
How do you manage the fact that some location can be connected through a VPN? Is it compatible with a connection with a VPN, because there are some private IP? So
yeah. So it depends on the agent. There are, within the data agent, we run two types of agents. One is called Globus Connect Personal, Globus Connect Server. Globus Connect Server requires in-out. It has to be both ways, firewall has to be open. Globus Connect Personal can work in completely native situations. It's only outbound. So you could put it there. Globus Compute only requires outbound connectivity. So it's I want to say yes in general, but there are certainly circumstances where if it's completely blocked and you cannot open any ports to the cloud, like to our services that we're hosting in the cloud, then this won't work.
Okay.
Right? But there are agents which can work in outbound only mode, so that you don't have to open inbound connection.
Because in the labs, usually the people connect with VPN to a supercomputer, no?
Yeah. So there are the ESNet, which is Energy Sciences Network here in the US. We have worked with them for a number of years. They are the ones who have provisioned a lot of these research networks. with them, we have come up with sort of these paradigms called data transfer nodes, which are sitting on the edge in their own network domain that can still mount the storage system, but they can also connect out. So the compute system is never connected out, but those things can, right? Yeah. So there are models where you run these. And then the compute agent typically runs in a machine that is like your login node. You know, login node, you're allowing somebody to connect, it can run on a machine that looks like that login node. So one more plug before we have had lots of HPC Wire awards, and these are some of the recent ones from the Globus. And the nice things about these are all impact-based, right? These are not product. The R&D awards was for product, so this one is nice. It's very much about the science we've enabled and such. And a testament, I think, to the fact that we are an open platform with API, with so many comprehensive set of services. It's not just a data movement tool, is the fact that national cyber infrastructures have adopted Globus and made it possible for their users, right? So in several countries, like Digital Research Alliance of Canada uses Globus and makes it available to all their users. ARNet is a huge supporter of Globus, and they have been a subscriber and user. NESI in New Zealand, South Africa, and here in the US, several projects are using that as well. So national cyber infrastructure use. Just very quickly, in 1 hour, it is very hard for me to do a demo and talk about areas. I want to get to revenue, but I just throw out a few things. And this is, I should put a ... in this slide. This is thoroughly incomplete. If you want to find another hour, we can talk about this. But so where are some of the things we are actively investing? We are looking at how do we, if you remember on one of the slides, I said there were 3 stakeholders we worry about: the researchers, the administrators who are supporting these researchers, and then the developers, right? So we take very deeply the administrators piece as well. In fact, we talk about you should be able to run Globus Connect and make your storage system available without having a full-time person manage it at all. And one of the things we're doing is expanding the capability for an administrator to come in and see how their file system is being used, and where are the files and how often they're being touched, and all of that. So that's an active investment area. We're also sitting, I think, on a gold mine of services, which all can be put together to do some interesting things. For example, a place we're investing is to try to figure out the right solutions we can build that put transfer and compute and flows together. So in place of telling you, build a flow that you need, we can see the patterns, and we're building these flows and offering that as a product rather than leaving it. So one example I'll give you, a lot of the investment here in the US for secure data management, they are setting up these enclaves, secure enclaves, so that people can use it to meet some compliance standards. There, they need policy-driven automation. If somebody tries to bring files in, they want to automatically scan it, administrator has to approve. They want to take file out, there's a process. So now we have a policy way, in the Globus transfer service, you can set a policy that says, anytime a transfer is submitted, run this flow. And the flow can do whatever you need for a policy. So we're trying to build and invest in those kinds of things where you're more a solution piece. I already touched on this, agentic AI. Our labs team is heavily involved. We're looking at that. And then for us, definitely the compliance regimes are growing, right? The research compliance is changing field here, and we continue to invest how to make it easy, again, to meet your audit requirements. And because it's a hybrid SaaS, it's a shared security model, right? We do some controls, they have to do some controls, the institutions, but we want to provide them the tools and the ways to configure things to meet. So that's another big investment area, and many, many more. So I know I started late, and I'm at 10:11. Do I still have 5 minutes? Where do you?
Yeah.
We shift.
Yeah.
Okay. Just wondering how quickly I go.
No problem.
I do have a flight to catch, so at some point I got to stop. So somebody asked me, we are a freemium SaaS, right? So the basic features are free for any nonprofit research usage. Doesn't matter where if you're a nonprofit research, university, labs, independent research, it's free. And the basic features mostly are around data movement. All of that is free. And then we have some limits on other things. The subscriptions provide enhanced features for users. Data sharing is a paid feature. Administrators get more, audit and visibility. We have this thing called console where you can see everything that's happening. We also remove and increase limits, and then they get priority support if you subscribe. But any compliance you need, if you're touching PHI, PII, you have to have a subscription. We have to have agreements with you. We have about little over 55 US institutions who have a BAA with us to do HIPAA regulated data at this point, right? And we have a little over 250 subscribers, institutions worldwide who are subscribed. So there is still a lot of free use of Globus. You sort of look at users versus this. The way we price this, it's an annual flat subscription and it's an enterprise-wide subscription, and there are no limits. So once a subscription is in place, any number of users, any number of deployments, any amount of data, any compute, there's no limits there. And the pricing level is determined by the research budget of the project, of the institution, right? So not the operational budget, but the research budget. We use it as a proxy for how many people may use it and how much they may use it. So even in a hospital system, we use similar methods. We find one of their budget lines and we price them, and then and there are separate subscription tiers for sensitive data. So if you want to do PHI, that's an uplift. That's a different premium uplift. And all commercial use requires a subscription, and they have a completely separate pricing tier. There is a premium subscription for them. No free commercial use is allowed on the service, right? So typically our buyers, let's see, okay, target segments, let's talk about this, right? I talked a lot about research universities. That's our big target segment. Research universities, US national labs, supercomputing facilities, both here and abroad, US agencies, we have federal agencies, many of them are subscribers. Sequencing centers, independent research institutions, those are another big one. And then we do have some commercial use subscribers, and most of them come from the research arm of the commercial company. And many of them come to us because they may have heard of us through a university partnership or something like that. So we do have a lot more in pharma and biotech for sure, right? Our typical, yes?
Did you play any role in the research of vaccines in COVID?
A lot. So, what I mean by that is, first thing we did was we also waived subscriptions. So we told anybody who's doing COVID research could use Globus for free for that year. So that was our way of pitching in. A lot of the universities who were engaged in the research or national labs that were looking to either do compute on that, or for example, the APS example, advanced photon source example I showed you, all of them were doing COVID structures at that time. So people pivoted to doing research in that, and many of them are using for moving data or using it for constructing data sets that they were then sharing out. There was a national virtual laboratory that was set up as a rapid laboratory to put people together that used Globus for moving and sharing data. So there was quite a bit of usage at that time. I joke that, somebody used the word plumbing, I joke that we are infrastructure service and we hear from people when something fails. But getting people to tell us success stories is not an easy endeavor. So if you are a subscriber, or even if you're a researcher and you're using Movement, I may never know exactly what you're doing. We don't require you to tell us or anything. We usually find out by doing outreach and telling people. We would love to hear stories about it. So, but what we know only because of support tickets, like where people wanted to rapidly open things up or some things like that. So yeah, it's used quite a bit. We can send you some of the user stories that we know that are directly related to COVID. A couple that I showed you are actually.
But you can also use user feedback in order to improve the product.
Absolutely.
It's an input to your R&D.
Yeah. No, absolutely, yes. We look for patterns and try to use that ourselves. So yeah, absolutely. So within these are, usually it's the research computing center. Most of the universities, national labs, all of them have these research computing centers. Either sometimes they're under the CIO, sometimes they are the vice provost for research or vice president for research. Those are our primary buyers. Although we are starting to see it expand to enterprise because, researchers are using things like Box, Dropbox, or larger storage, which tends to be enterprise, but typically that's sort of how it starts.
So this is open source software?
No.
No?
The cloud-hosted services are closed source and IP protected for University of Chicago. The agents are open source software.
Okay, but why the reference you mentioned on the previous slides refuse to say to say that they are using Globus? What?
So it's not that they refuse. Routinely, research institutions, especially that are state funded, is here for sure, typically have a clause that says that this could be construed as endorsement. So we'd have to talk to them before we put anything, right? If you go to our globus.org/user stories, I think is the page, there are tons of user stories with these institutions. So they are willing to say it, but in that context, and they would have to get permission. So it is that distinction, essentially.
Yeah. Do you think it's due to the current situation, global situation, I mean, worldwide?
No. This has been the case for 30 years. Yeah. I don't think it's a...
The fact that some of these institutions receive some, let's say,
federal
national fund and finally pick external overseas solution.
Maybe. So my opinion is not driven by it, only because this has been the case across multiple administrations. Okay. If this was a new phenomenon, I might also wonder that, but it's not, right? And it's common even here in the US. It's mostly a lot of the contracts essentially don't want them to be perceived automatically as endorsement. You typically take permissions, that's all. That is all the difference. Many in that list have a user story. So I could have, Rose and Franklin have presented in our user conference. Many of them come out, present at our user conference, do joint events with us. But commercial companies will not, obviously.
So we see the value of this. So what can they use instead of you? I mean, if they identify their need, they say, we can build something ourselves. We can pick, some commercial software, if some exist, or multiple of these, or Globus.
Yeah. And
finally, they realize that outside Globus, there is nothing that can do all the things you deliver, no?
Yeah. So definitely there are other tools. There are point solutions, right? If you're moving data just from a couple of typical vendor solutions, there are point solutions you can use. But a platform that allows you to build on it and use all of these different services, there is no direct right now.
Yeah, and a global, planet-wise.
You can think about it, right? You have all these endpoints all over. You have collections that are available, data storage systems available through Globus all over, and we are already plugged into your institutional logins. So that really changes the federated authentication. And the federated authentication is coming from research federation networks. There are two very big ones, one called InCommon here in the US, one called EduGain in Europe. ARNet runs one in Australia, and we are plugged into all of these. So it's readily available. You just kind of go in, you can find your collaborators, you can add them and use it. It's mostly inbound sales for us. It's not like we do a majority of it. Our people just reach out. We do some opportunistic channel sales. A lot of it has been driven by customers asking for it. Typically, they get 90 days free trial for using things. And then it's all self-service deployment, right? People just go through it. And then we have a dedicated help desk, much like you would expect, with levels of escalation and priority and such there.
So finally, University of Chicago start a business. It's a business for the university.
Yes and no. We are an auxiliary unit within the University of Chicago, and the subscriptions is what funds our team. So I must say the Globus department within the university has two groups. One is the Globus platform team, and one is the Globus labs team. Most of what I've described here, producing the service, operating it, and all of that is done by the platform team. The Globus Labs team is a classic research organization. They're postdocs, researchers, research software engineers, and it's directly managed by Ian Foster and Kyle Chard. And you can think of that as a company's research arm, right? The flow service, the compute service, all came out of research in that space, where we had grants to do some work on that, and then we realized the product potential and took it and commercialized it, if you will, right? But we remain a nonprofit. We are part of the University of Chicago. We are not a separate legal entity. So we remain a nonprofit, and the goal is still to sort of sustain the software. So different goals in how we do this, and even how we hire people and how we set up our business operations.
Good, thank you very much. Any other questions before we conclude?
It might be a slightly naive question, but can Globus be compared with WeTransfer? Does it make any sense, or is it like compare a bike to a truck? Yeah.
Can you compare?
WeTransfer service. Do you see any similarities, or it's quite different?
WeTransfer can only share globally file.
Yeah, no.
Yeah, so again, this is a question for a point solution. You know, if I take only the sliver of our transfer service, then maybe I have to look at how it fits in the market that we are serving, right? Is it plugged into an institutional security system? Can it do high performance like we do? What are the controls in there, sort of thing? So you would start to compare capabilities, if you will.
WeTransfer is like a calculator. Globus is like an iPhone.
Yeah.
You know, big difference.
I mean,
both can do calculations, but
You like this one?
the calculator.
I mean, this is well. So actually, that is a good. It's not an Android. It's like an iPhone because we manage the ecosystem. But yeah, but again, this is where I go back to say point solutions you will be able to find. I can't say no, right? Mm-hmm. It's the platform that I think is the way, and the security.
Transferring hard disk by courier, you can do that. But who would do it when you've got petabytes? You'd be
That's
mad.
right. Or even if you have less, because you have corruption. I mean, there are real downsides to doing that.
So we can say that Globus is like WeTransfer for very, very big files.
You could do small files, you could do big files. It's one aspect. Whatever that does, for Globus, it's one aspect of Globus. And what we do really well is the reliability aspect. We have the great network. There is Globus deployed all over so that people can just move data there, right? So all the reliability checks in, the performance. I don't know how we compare directly with it, but that's sort of what we do. But he's right that that's one sliver of the product. And there are many such. You know, I mean, reliable file transfer is a whole. There's a industry around it. But it's again point solutions and the comparisons to the kind of platforms that we support or what we are able to do in terms of reliability and heuristics and optimization. That's kind of where can they work on a 400 gig network and make the most out of it? We can, right?
And then once again, there's no real competition to Globus. I mean, it sounds like you're the one-stop shop for data transfer, for collecting things from in the field. I mean, it sounds like you
as a
this
platform,
overarching solution
as an overarching
that has grown
solution.
to be so capable.
Yeah. As an overarching solution, yes. As point solutions for each of these, we can certainly list things. So whether somebody wants to pick up these point solutions and put them together, that's a different thing. I'm sure maybe some marquee cases, where a particular tool may do really well in one area. You can think of us as sort of that Swiss Army knife at that point, right? We can do lots of things and provide that broad platform for using it.
So Alex used the A word earlier, and I'm looking at this last slide where it's got documentation support, and I'm assuming the documentation is probably extremely large based on all the things that we've talked about and what the platform, the connectors, and everything can do. I wonder, are you using any AI to, go through all of your documentation and to offer some type of support or to teach you how to build a connector, or how are you using AI
so,
at the platform layer?
Yeah, I mean, certainly we are looking, some of the engineering team is looking at, AI tools for being able to do things like developing tests and such, being very careful because we have compliance requirements. So we have to be careful about what we use and what we do there. From the documentation side, we are actually starting to explore what we offer. But on the other hand, even if you go to one of these state-of-the-art models today that is available to an average researcher, average user, and you go in and say, look, using globus.org and docs.globus and the YouTube videos that we have, answer this question. I don't know that there is that much more retraining we would have to do. So we don't have an AI chatbot agent on our website yet. I think it's going to have to meet high standards to get on our website. So we haven't, but the standard tools do a very good job given our documentation on that. Some of the approaches we have thought about is adding some of these LLM.text, supporting those things. So that's an approach we've been taking on trying to see how we can augment that. Yeah.
Good. So I think we can conclude the session here. Thank you for this very dense in 1 hour, as you said. It's not an easy job to do this, yeah, because I realized that finally the software is contain much more things than I expected or I knew in the past, and it's now a global solution, as you said, a platform. Yeah, you can do so many things, especially with the recent compute agent, etc. Yeah, so thank you for that. I hope you appreciate the interaction, etc., with the group and different questions, even some anticipation.
Yes, yes, setting up. No, we greatly appreciate first the invite.
Yeah.
We appreciate you reaching out and including us in this. We don't do too many of these, so this is great. And I was talking to when met Susan this morning. I was telling her 1 hour. It's a lot of compressed material.
Yeah.
So we are happy to follow up in any way that makes sense, right?
Yeah.
Whether it's deep dive on something specific, or whether it's giving you additional materials, or I think somebody's interested in some use cases, so we can provide what would be useful. So as you
I think one of the interesting aspects would be probably to share a list of references in Europe and in Australia and in US. Some people we can probably speak potentially if we want to illustrate or connect with in order to have their return of experience on this. Yeah.
Or if you have a YouTube channel that has, because we didn't get to see the actual platform.
Yeah.
That might be.
I debated demo versus not, but given my 1 hour, the demo I could,
Demo,
yes.
For sure.
So we'll follow up with pointers to the YouTube. There are lots of videos there for each of the product. There's video series, so yeah, we can certainly see. And I don't know how follow-up works, but if we want to set up a web call where we quickly do this or we review some of it, I'm happy to do that as well. We do that all the time for our customers, just very quickly get on calls to do webinars, so we can do that.
Good. Thank you very much, Rachana.
Thank you very much. I appreciate all your time.
Thank you so much.